Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'm going to talk about naive-Bayes theorem. In my previous video, I've already explained the meaning of Bayes theorem. In this video, will be first understand what's the meaning of naive-Bayes theorem. And in the next video, which I'm going to put, in which I'll be explaining how we can implement the same in RStudio. So let's get started. So we already have discussed about this formula in the previous video. In case if you haven't watched that video, I'll be putting up the link in this video, which is the base of this, because I've already explained in the previous video that Bayes theorem will be serving as a base for this naive-Bayes, and now this video will be serving as a base for your upcoming video, which is implementation part. This is the formula which we have discussed already in the previous video, which is nothing but the Bayes theorem formula. Now, what's the concept? For this video, I'm going to take a scenario in which we are having total 30 points available. All right, we have two features available, salary and age, right? We have two categories available, walks and drives. Meaning is we are having some set of people, and we have some people are walking for their work. Let's suppose they are going to work via walking, and the people who are going to their work via driving. All right, so let's suppose we have a new data point, this gray point, right? We have to classify it into either category. Means we have to classify based upon the features salary and age, right? And we have to classify it either in walks category or drives category through this naive-Bayes algorithm. All right, this is we're gonna do. I hope the thing is okay. We have a total 30 30 observations, in which we have some of the observations are for walking, some of the observations for driving. And if we have a new data point available coming up, in our case, we have to classify it either in walking category or driving category based upon the naive-Bayes algorithm. So how it works? The step one is we have to use this Bayes theorem two times, one for walking, one for this driving. Okay. The step one is we have to first apply the Bayes theorem for the walking. So what's the formula? We have to use the same formula that I've shown in the Bayes theorem. In this case, this A replaced by walks, B replaced by X. Here X means features. So what are the features? Features are this: salary and age. All right, let's suppose this guy we are placing it here, whether he'll go to the office via walking or driving. Let's suppose this is having the maybe age as 30, and this is having maybe the salary as maybe 30,000. all right, these are the features. These are the features, which is X. So how we can represent this? This is a conditional probability. We already discussed in a previous case that probability of the person who is walking given the features. So features are nothing but age and the salary. Okay, this is called as a posterior probability. These are the terms we have to remember. This is the formula is equal to likelihood into prior probability over marginal likelihood. So these are the things we have to calculate. We have to calculate, you can see the numbering. We have to first calculate the prior probability. We have to then calculate the marginal likelihood. Then we have to find the likelihood. Then we can able to get the posterior probability. I've already explained that we have to apply this Bayes theorem two times, one for walking, one for driving. This is step one. So in a step two, the same thing we have to apply for the driving. As I've already stated that Bayes theorem we need to be applied two times, one for the walking, one for the driving. In the first case, we'll be solving it for the walking. Second case, we'll be solving it for driving. And third case, we'll be comparing whose probability is more. Let's suppose if the probability of walking is more, then we have to place this point in the walking category. If the probability of the this driving is more, we have to place that new data point in the driving category. All right, the formula is same. We just have replaced walks with the drives. Now the third step, the last step of this algorithm will be we just have to compare the probability of the first and the second. Means whosoever is having the more value, we have to place data point in that category. All right, so this is just a three-step process, naive-Bayes theorem. First step is to apply Bayes theorem for walking category. Then apply the Bayes theorem for the second category, which is driving, and third step will be comparing both the probabilities. Now how we can calculate the step one? For step one, I have already told you we have to calculate three things. First is prior probability, next is marginal likelihood, third is likelihood. Let's first calculate the first step, which is the prior probability. The prior probability is very straightforward. In this case, because we are finding for walking, as I've already told you, in total we have a 30 observations available, and those who are walking, you can see, you can easily count, it's at 10. All right, so this can be calculated by P walks equal to number of walkers divided by total observation, which is 10 by 30 means 1 by 3. This is how we can calculate the first step, which is the P of walking. Now we have to find the second step, in which we have to find the P of X. So what is second step? I've already told you, it is the marginal likelihood. So marginal likelihood can be calculated with this formula. in which we have the number of similar observation over total observation. So you must be wondering what this circle is all about. Actually, the second step, what we have to do is we have to make a radius. This radius, it's your choice. You can make a bigger radius also, you can make a smaller radius also. So let's suppose we've made this radius, and this is a gray point, okay, which you can see in the middle, and then we have a 3 red points in the vicinity, and we have 1 green point in the vicinity. All right, so in this case, how we can calculate the second step, this marginal likelihood? It says that equal to number of similar observation. So let's what we have to assume in this case is the when we make a radius, okay, we have to assume that the whatever the features like these points are exhibiting, these are the same feature this is exhibiting. Okay, we have to just assume that all of are almost the same. All right, so in this case, in total we have a 4 total points available. Just you have to ignore this because it's a data point which is coming up right now. It is a gray data point. You just have to ignore the middle one, but now just count the number of points which are coming in this vicinity, in this radius. Okay, these are total 4, and what are the total observation in total? We have a 30. So 4 by 30, it will be your marginal likelihood. I'm again repeating. For the second step, we have to make a radius. This radius can be of your choice. It can be small also, it can be big also. It's up to you, right? So in this case, as we made a radius, total 4 points are enclosing in this. So this will be coming in numerator, and total observation will be coming in the denominator. So it will be 4 by 30. This is how we can calculate the marginal likelihood. So third step is to find the likelihood. So how we can find this, the third step, likelihood? In this case, we have to go with this formula, number of similar observation among those who walk over total number of walkers. So as you can see in the formula, we are talking about only walking. It means you have to ignore the green points. It means because we are talking about walking, it means only red points will be considered for this step. So overall, we have a total 10 points are available which are for the walking, right? That's why under the denominator, in the denominator part, we have a 10. And why it is 3? Because only 3 are coming in this radius. The 3 red points are coming in radius. That's why it is in the numerator. So I'm again repeating, because we are finding the probability with respect to walking. Okay, so only walking, this walking thing will be considered, not the driving thing. It means only 10 points will be considered for this step. So 10 points, or this 10 number, will be coming in denominator, and because the 3 red points are coming in this radius, it will be in a numerator. This is how we can find the likelihood. So we just have to put the formula in the in this Bayes theorem, and we'll be getting the 0.75, and with this 0.75, it will be called as posterior probability. So we have found the posterior probability for the ones who are walking. Okay, so the same step we have to repeat for the driving as well, the same step. So instead of now counting the green one, red ones, we have to now count the green ones. In that case, we will be getting the answer as 0.25. all right, so okay, you can easily now calculate which is more, walking one or driving one. Obviously walking one is more. You can see the third step, we have to compare the walking with the driving. So obviously we got 0.75 in the walking and 0.25 in the driving. So it means 75% we are having in walking and 25% is in driving. So obviously the probability of walking is more than probability of driving. So we can easily say now that this point will be considered for the walking. It means this new data point will be classified into the walking category. So this is how this Bayes theorem works. I hope you must have understood this simplest of video in which I've just explained how Bayes theorem works. In next video, I'll be explaining how we can implement the same in RStudio. So thanks for watching, guys. See you next video.